Hi, I'm Frank Bertholm. Today I'll be showing you a workflow to develop model-based tests using MISTA and Selenium. To follow along with this workflow, you're going to need Java 1.6 or better, a copy of MISTA, and the Selenium IDE for Firefox, all of which can be obtained on the web. During the process of this workflow, we're going to determine the basic properties of our system under test by viewing it and playing with it a bit, use Selenium to extract the necessary commands and controls to execute our test, design a model of the system using MISTA, then connect the model to our system under test using the Selenium commands obtained earlier, and then generate and execute our Selenium code to actually have a useful test. Start off by examining the system under test, which is going to be the light switch example at virtuousprogrammer.com. You will note that we have two components of interest, the state label and the button which acts as a switch. You can click the button and it will flip the state. We have two states, either on or off, and you can notice that the initial state will always be on. Now that we've examined the system under test, we can get a closer look at the components using Selenium. So if we go into Tools, in the Selenium IDE, the IDE opens up. Notice that when it opens, it is already in record mode. Let's record a couple of actions, and click the button to flip the switch, to take a look at the value of the label by asserting what the text value is. You will notice that when you start it up, it also used the open command, which will open the page. Unfortunately, it just opens the directory, not the full address. So I am going to copy in the full address for ease of use later. It also recorded the action click and the identifier, button switch A, assert text, identifier light, and what value is being asserted. We'll use all of these later on when we are connecting our model to the system under test. Now that we have a decent understanding of our system under test, we can create a model that describes it. So we open MISTA by double-clicking on its jar. System will start. First thing I generally do is create a save folder and file for my model. So I create a separate folder because there are generally several files associated to any given model. And it's nice to have them all in one place. I'll simply name the model the same thing, light switch. Save. Now take a look at our design environment. We have a canvas, a standard select tool, a place, which is similar to a state in a finite state machine, transition, which describes change in state, an arc, which connects places to transitions, and annotations, which can be used both for comments and also for messages to the model compiler. So the first thing we will do is create a state for on, create a state for off, and then add in transitions to turn on and turn off. Then appropriately label them by double-clicking on the place and naming it on, off, and then double-clicking on the transition, naming it turn on and turn off. We'll use arcs to connect our places and transitions. So you click on the place, to the transition. When you're in an off state, it can turn on. Then click on the transition, then the place. To turn on leads to on. And repeat the same from on to off. Now you'll notice we have arcs running through our text, so we can drag our text so that you can see it clearly. And one last step to create our model is to set the initial state, which is on. So we grab an annotation, type in all capital letters, init, and on. And this is our model. We can now verify that the model behaves as expected by running the simulator. So click the simulator. It's easy to see. You can see by the token that the initial state is on, and a red colored transition indicates that that transition can fire. We hit play, and now the token is in the off place, and the turn on transition is available. One more time to verify that turn on works. It is now in the on state. We verified our model works. We're now ready to move on to the next stage. Now that we've created our model, we're ready to connect it to our system under test. The first stage is to select the appropriate controller. Java is default. We want to select HTML, which is for the Selenium IDE. The text is included because I'm working on a slightly smaller than average screen. Then you go into the MIM tab, for which there are 4 sub-tabs. The 2 that we're interested in right now are methods and accessories. Methods connect other transitions into commands in the system under test. We have 2 transitions that we're working with: turn on and turn off. For ease, let's get a look at our commands from Selenium. There we are. So the command that turn on and turn off is to click the switch. Command click, lowercase. I copy and paste as much as possible to avoid typing errors. And we are targeting button switch A. And that's all we need to control our system. Accessories will take the states or places and verify them. So we have 2 states, on and off. Our accessories will be to assert text, again copy paste, with the identifier light, and when the model state is on, we will assert that the text in the label is on, and similarly for off. The final step in connecting to our system is helper code. What we need to do is set up the initial setup code so that we start in the right place. You need the entire HTML chunk, so you're just going to copy this row and paste it straight in. And with that, the system is connected to the system under test. MISTA has a variety of options and configurations for generating tests, but the defaults work pretty well, so that's what we'll start with. So if you go to the Generate Test icon, give it a click, and your test has been generated in an HTML format for reading by the Selenium IDE. Control S to save, and you can go over to the IDE. No need to save what we're using for a scratch pad earlier. Select the generated light switch tester file. You will now have your tests neatly lined up. Only one test because this is a fairly simple model. Open up our browser so we can actually watch this run. Take it down to about mid-speed for watching, and run the current test case. And there you have it. That's all that's required to create model-based tests using Selenium. Thank you for watching.